Hello and welcome back to Pure Science Education. Today we're looking at graphs. Graphs form a really important part of the science GCSE. As you will notice, in all three sciences, biology, chemistry and physics, you will have a graph question. Graph question can be represented in different ways. You can be asked to plot a graph or analyze a graph or do evaluation of a graph. It could be a line graph, pie chart or bar graph. So this comes up a 5 to 6 mark question. So if you can earn those 5 to 6 mark questions, but understanding how to plot a graph and how to read a graph, then those are the marks you can go in with already. So how do you plot a graph and what we look at when plotting a graph? When plotting a graph, a common mistake that a lot of students do, they tend to use the results and use that as a scale, which is incorrect. You need to choose a scale. Now, to choose a scale, um, you want to use as much possible of your graph paper. So if you use the entire graph paper, your points will be spread out and you can see for any anomalous data and any errors or any pattern clearly, rather than if you squash your graph into a small place where you can't see all of this happening. A general rule is that if you can make the scale on the x-axis or the scale on the y-axis twice as big while still fitting all the points on your graph, so your graph is not too small. So the whole idea is to spread it out as much as possible. Now make the scale a simple one so it's easy to plot. So if one square is 1 unit, then one big square can be 2 or 5 or 10. So what I mean by that is if you have a graph and on the graph you see these squares, we are talking about this one square. That one big square is equal to one unit or 2 unit or 5 or 10. Now, obviously, trying to stick to even numbers are not random. Go up in a particular fashion where the data is also looking positive and it works for you. Now, your scale needs to be consistent throughout the graph. So if you go up in 5s, you need to go up in 10, then 15, 20, 25. Or if you're going up in 10, it'd be 10, 20, 30, 40, 50. So it's got to be consistent. You can't just randomly start introducing any points where you like. And like I said, some students who think that their result is the scale that end up getting a random scattered data as a scale. Now, once you've decided on your scale, which is nice and even, now another clue before I move to variable is to do your scale, look at the smallest and the largest value and then see how many squares you have to fit the entire data and then decide if you want to go up in 5s, 10s, 15, 20, whatever allows you to fit your data on the graph. Now, the next thing you need to do once you've decided your scale is look at your variables. Another issue with some students that don't know both data is numerical, which side they need to put what. Now, the thing you need to remember is on the x-axis, you're always going to have your independent data. So independent is something that you deliberately changed in your experiment. And on the y-axis, you are going to have something called the dependent data. Dependent data is something you're going to measure as a result of what you change. So if I have decided to change the temperature and I'm measuring the height, then the temperature will go on the bottom and the height will go on the side of the graph. So once you've decided these, then you can start plotting your graph. Now, when you label your axes, please make sure you have the quantity and the units so you know what you're talking about. So time is in seconds, mass in grams, temperature in degrees centigrade, force in Newton, velocity is meters per second. So whatever you're measuring is very good to have your units because you will be asked to put that to get full marks. Now, the different types of graph, like I mentioned right at the start, if both your variables are measured in numbers, then you're drawing a line graph, which in maths you call a scatter graph as well. Variables like these are continuous, so time, temperature, mass, current, acceleration, and so on. But if one of your variables is not measured in number, then you draw a bar graph. So bar graphs are normally categorical, so they are types of things, or one you will get some data that is in words rather than numbers. So an easy way to remember is if you have two numerical columns of data, which is continuous data, you're going to do a line graph. And if you have data where one column is words and the other numbers, you're going to plot a bar graph. So it's not normally correct to join dot to dot in sciences where it is in maths. So please be careful if you're doing a maths or a science graph, because they differ in nature. Now, the word line best fit, the line best fit, it confuses students because they assume it's dot to dot because it's joining all the points. But in science, the word line of best fit means it's the line that goes through most points, ignoring the anomalous data. So a word anomalous means something that doesn't fit the pattern. So here you can see you have got breaking distance in meter and mass of car in kilograms, and the line of best fit goes through both sets of points rather than dot to dot, and has similar numbers of points which do not fall on the line on either side of your graph. Here's another example where the data is going downwards, heart rate and hours of exercise. Again, similar trend. You're trying to get as many points as you can on the line, but as long as you got even numbers on both sides, that's also acceptable. The line of best fit can sometimes be a curve. It's particularly important in science. You do tend to get a lot of curve graphs where students are trying to draw a flat straight line with a ruler, which is incorrect. So trying to follow the pattern of the points to see if it's a curve or if it's a straight line. Now, one of the clues I can give you here is if you're not sure if it's a curve or a flat line, then turn your graph paper upside down and then follow the points, and you will clearly see if it's a graph or a flat line. So here it's a curve, as you can see, and again most points are on the line if not nearby. There's another curve where points are going pretty much closely onto the line. Now this is called an intersecting line of best fit where energy changes. So again, this is slightly different where you got positive and negative, and you will be told to plot something like this. So this tends to be a flat line and going up, and then a line going up or down again, depending on what's happening there. Now, reading values of graph, you need to be able to draw lines going upwards and across. So an example is here. So if I want to read, I can go follow my green line up and then go down across on the graph. Make sure that you're touching the line. The points are touching the line and not randomly anyway. As long as you do both sides equally, you should be able to read it on any of the line. Now, in a higher GCSE paper and a triple paper, you will be told to plot the gradient of the graph, which is the area under the curve, which you use in maths, but in science we call it the gradient. So you draw a triangle where you do y divided by x, and then you can follow out the calculation for the gradient. Here, if the graph is a curve, then you need to draw a tangent. Again, something that comes up a lot in the higher or triple paper. So this E to F is a tangent line. Once you've done the tangent, then only you can draw a triangle and then do your rate of reaction, for example, which is y over x. Now, like I said, in maths, you will do something like this, which is called area under the graph. Now, the final bit we want to talk about is how do you describe graphs. So variables are directly proportional if they're going up in the same rate. So if x doubles and y also double, that means it's directly proportional, and you tend to get a straight line through the origin. If you got inversely proportional graph, then if your x doubles, then your y will halve, so they don't tend to go up at the same rate. And finally, as time increases, the volume also increases. So this is this graph you need to break into two, because you can see here something different starts to happen. So you can talk about two halves of the graph. That at the start is a quick reaction, so it moves much faster. Eventually, the reaction stops, or the reactants have been used up. Then you kind of get a plateau, a flat line. So, like I said, graph in all three sciences are quite critical. You are definitely going to get graphs to solve in all three sciences, and they can be in any form or shape. In terms of analysis, evaluation, plotting, reading, using the data, and so on. All the best. Thank you.